Hi, this is Pinchao Liu from Always Research Lab. Today we are going to go through the paper we published in the IPDPS 2020 conference. The paper title is FP4S Fragment-based Parallel State Recovery for Stateful Stream Applications. So we are going to go through the infrastructure design, and then we go to the demo part of the software. So the software has three layers. So first layer is based on the physical network. Based on the physical network, we created a DHT-based ring overlay. And then the second layer is the DAGs. The DAGs is related to the stream processing application. So different application will have different DAGs. And then the top layer is the FP4S APIs. For the APIs, we will have different interfaces. So we will have the encode, the save, the retrieve, and recompute. And the main purpose for this FP4S infrastructure is used to deal with the failure recovery when the failure happened in the stateful stream applications. Then we can quickly recover the original state to let the application to continue run based on the previous results. So we go back to the source code. So clear the command line and then remove the previous result. So you can download this paper, and you can download this paper from our lab website, and then you also can download the source code from GitHub. It's open source for your research purpose. So for the DHT part, we do the customization based on the open source software. It's named Pastry. We also will provide a link in the comments part. For the second layer is the we do the customization based on the popular stream processing application platform. Is named Apache Storm. And then we build our own this FP4S API. The methodology in backend is the original code based on the RS code. So we go to the source code. We quickly take a look about the external libraries. So we do the customization for this. The software is named FreePastry. The version is 2.1. is about the DHT layer, and we also have this RS code library. And then for the rest of them are majorly related to the Apache Storm. So we do the major customization for the Apache Storm is to have to give the boat to let it has a have the capacity to save state. So here you can see you can call this function to save the each tuple input. To call this function, this is the so we'll create the abstract class and abstract function, and then implement the function to let each bolt to have this capacity to save the state. So by default, it's just deal with the state instead of saving it. So we give this capacity to the bolt component. For this demo, we will create a topology. Topology is the most simple one. We will just have the just have the spot and the bolt. So the spot is used to generate the information. The bolt is used to deal with the information. So in this case, we just save the information. In the bolt, we just save the state instead of giving it a complicated logic in the bolt part. But if you like, you can do you can deal with the information and then save it, or you also can save it before you deal with the information. It's based on your design. Both of the way will be working, since you can call this save state function anywhere within the bolt component. So in the paper, we also compare this topology with another checkpointing topology. For the checkpointing methodology, for that method, you need to save the state to the HBase to HDFS. So you also kind of play with that. And then here we also give some other ways to let you to compare, such as you save the state to DB or save the state to the path. The path is also a P2P file system. So there are some other ways to do that. So today we are just majorly to dive to how to keep the state into this FP4S, and then in the backend is use the ICE code topology, ICE code methodology. For using that method, we can instead of save the state into a single file, we save the state into different files, several files, and then when we do the recover, we just need partial of the files. Then we can recover the state, the original state. So we just quickly run this part to see we just save the file, and then based on the ICE code to separate them. To launch the application, it will take a moment, because it will launch the Storm components such as Zookeeper and Nimbus. We just stop here, since it's a stream processing. It will keep running, but since we already have the files, then we can take a look about the saving state. Yeah. So here is this is the original state, just for the reference purpose. So for the separate files, the states, then we can take a look about them. They just keep each of them just keep partial of the information, but some of them are not human readable, but they based on the backend matrix calculation, we can use partial of these files to restore back to the original state. This is the matrix calculation in the backend, and then this so for the how many files we need to use for restoring the original state, it can be configured by user. So there are different setup. We perform the experiments in our paper. If you are interested, you can check them. So let's quickly go to the experimental part. Yes, so this is the number I was talking about. So we have the raw fragment, and then we also have the parity fragment. So we adjust different parameters to check the results, and we also check this arrow, the unavailable block numbers, which that means this part of the file is already failed. The node is down. Then we can not get this file from that node, but it's still able to restore to the original state. So there are some other detailed information in the paper. If you are interested, you can go through this paper. If you have any questions or concerns, just send an email to let us know. Then we can discuss further. So you can find our contact information from this paper. I will list this paper download link and our source code in the comments part, and the other some referred software such as Pastry and Apache Storm. Thanks for your time.